So hello, everyone. Thank you for joining us today. I want to make sure if you haven't joined one of these before that you're familiar with the event tool. So look around and there's a chat on your right, and please tell us where you're located. Notice also in the chat box that you have a Q&A tool. We will be monitoring the Q&A tool, but not necessarily the chat. So it'll make us easier to answer them if you post your questions there. Just a few things to be aware of. We're taking questions at the conclusion, so please post them in the Q&A tool. The track will run for 59 minutes, and we'll get you out of here on time. And just want to mention, it would not be possible to run this virtual conference without our sponsors, so thank you, Influx Data, for sponsoring this session. So with housekeeping out of the way, I'd like to introduce you to our topic and speakers. So the topic that we're discussing today is navigating the data tsunami and the rise of IoT sensors in Industry 4.0. And personally, this is very interesting for me. I've worked with time series data for over 30 years in the chemical industry. And with the introduction of IoT sensors, we can now monitor everything. We have an additional mass amount of data. So this should be a very interesting topic for everyone. I'd like for the panelists to introduce themselves. Balaji, can we start with you?
Sure. Hey, Jen. It's good to be here. Good morning, good afternoon, or good evening, everyone, as you're joining from wherever you are. My name is Balaji. I am currently a VP product marketing at Influx Data. We are the makers of Influx TV. I'm coming to you live from the Bay Area, California. So excited to be here. I've been with this company about 5.5, 6 years now, going on to 6. And primarily I've been in the monitoring, time series, observability space. And this session is exciting to me because when I joined Influx TV, I joined as part of the product team, have worked with many customers as they have onboarded themselves with Influx TV. We are a time series solution. And they like to call ourselves for this use case, the modern data historian. So as industrial customers on board onto Influx TV, I've worked with them, and really excited to be here sharing some of the ideas and some of the problems we encountered together with them. Thank you.
Thank you, Balaji. Kelsey, please.
Hi, yeah, I'm Kelsey Hickok. I'm the Market Development Manager for Applied Industrial Technologies. So my role so far has kind of consisted of building this IoT product line. Applied Industrial Technologies is a really large distributor for pretty much any kind of equipment that goes into a factory environment. So we've done hardware for a long time, but as the trends and as the market's kind of moving towards using more innovative technologies, we've been finding that IoT is something we need to put our time and energy into. So that's kind of been my role, is just evaluating what that looks like for our company, what that looks like for our automation division as well, evaluating different types of supplier products, developing some software, some packages here and there. So just everything IoT, a lot of learning about the trends and about the market in this role so far.
All right, thank you. Well, we'll start with questions just momentarily. I just want to say that with the description of navigating the data tsunami, I think that is very appropriate. We're seeing an exponential increase in IoT sensors, annually. So it's really becoming more and more complex. So let's go into the questions. Kelsey, what are some of the key challenges manufacturers face when harnessing and analyzing the vast amounts of data generated by IoT sensors? And how can these challenges be overcome?
Yeah, I would say probably the first one that comes to mind is people kind of being scared to adopt some of the technology. So kind of biggest challenge kind of maybe themselves a little bit. So getting out of their own way, getting out of any prior thoughts or beliefs that technology is scary, that software shouldn't be implemented, not being kind of like afraid to fail also when implementing some of this technology. So that would be the first one I've seen, is people just not having enough motivation to fully get in for a purchase and deploying it. There's a lot of stuff going on in a factory. So in my eyes, IoT, a lot of customers kind of look at it as like a nice to have product. It's not like something they absolutely need in terms of production. So they have a lot of stuff going on every day, where is the motivation to actually put a purchase order into IoT, and when are they actually going to deploy it? So people are kind of the main challenge I've seen in terms of kind of old superstitions they have about software. Another thing I've seen a lot is the data integration. So sensors generate tons of data in various formats from various sources as well. So how do you bring all of that into one place with data being very siloed? There's kind of some skill and some expertise that is needed there that I don't think people have fully figured out yet. So a solution for that is just adopting a bunch of different types of industry standards and protocols for data exchanges, using different types of middleware platforms for bridging those different types of systems, which translates into just using APIs, data lakes, to enable kind of like third-party systems for facilitating that smooth data integration. I would say another one would be kind of actually like the data quality and management of it. So making sure the data is actually accurate, that you're using it in a consistent way, and that it's complete as well. So solutions for that, I don't know, using automated tools for pre-processing the data, doing continuous monitoring, setting up a schedule for when you actually want to bring that data in, and then really utilizing the edge computing power, so processing data as close to the source as you possibly can for that, so you're not kind of just sending big random not organized chunks of data into your cloud environments. So those I would say are kind of the main issues I've seen.
Okay, thank you. And I find it curious that manufacturers are hesitant to install IoT. If you compare the cost and complexity to the way it was been done historically with actually hardwiring everything, it's much more efficient and more cost effective to do IoT sensors. So I would like to next ask Balaji about some successful use cases for manufacturers where they can leverage the sensor data to drive operational efficiency and improve overall productivity. And I think having a clearer understanding of this will help with the adoption.
Yeah, it's good. In order to answer that question, maybe I want to step back and say, in today's industrial world, I think data is the currency, right? There are a lot of equipments out there on industrial floors and stuff like that, where you want to collect that data. Some of the use cases that I want to transition into are one of the things is I think you mentioned process optimization. One of the customers is like Heineken. We all know it's a very popular beer manufacturer with more than 150 kind of breweries located across the world. But what's there is they are $1 billion company, and every 1% transition or translation of output, increase in output translates to like millions of dollars of revenue for them. So process optimization would be one of the key use cases. The other would be, as you mentioned, in manufacturing situations, when you hardwire stuff, right? It's hard to change. Equipment break down, and you want to replace parts. So how do we do it? How do you find out in real time that hey, this part or this particular equipment is going to fail? So real-time monitoring of those using sensors, using many different variables like temperature. You can monitor vibrations. You can monitor acoustic things. There's so many things that customers do that help you identify, hey, what's going wrong with that process or with that manufacturing equipment or in the factory floor, the assembly line, and so on and so forth. So that's another use case where you're monitoring from a remote location. And last but not least, one of the things that we all have heard about in this industry 4.0 is predictive maintenance. Predictive maintenance is about how do we, collecting that data and forecasting when a particular part or when a particular process in that thing is going to fail, so that it can step in and kind of do some repair or maintenance or replace that part and so on and so forth. Might have missed a couple of things in that, but things like quality controllers is another use case where you monitor the output using sensors and kind of step in and either remediate the process so that you can improve efficiency and improve quality control within your processes.
Thank you. I expect as manufacturers more and more start to adopt IoT sensors and have more insights to the actual running of the equipment in their shop floor, that we're going to see an uptick in manufacturing. So I'm looking forward to that. I think it's slowly happening, and hopefully it'll speed up. I'd like to look at the business opportunities. And I was wondering, Kelsey, you could tell us about potential business opportunities and competitive advantages for manufacturers who are able to effectively harness and act upon sensor data in the context of Industry 4.0.
Yeah, I think the overall kind of like the biggest thing is just understanding your equipment a little bit better. So yeah, understanding it and getting trends, being able to read trends for like motor trends, for example, on how your motors or bearings are working. So using that and being able to just be able to predict when they're going to run out. So from like a sales approach and also like a downtime approach, just using those trends to help you make better business decisions for when you want to order those, and just, yeah, doing more of like an ordering standpoint of it. And then comparing kind of this data with some of the like supplier data as well to work together to just generate like a plan moving forward to make you successful with your equipment and just understanding it a little bit better. And then that just moves into optimizing your production processes in real time, reducing different types of waste, improving quality, and then just enhancing overall efficiency for your equipment. I would say a cost reduction would also go into some of the business opportunities for it. So sensors that monitor energy consumption, that you can optimize your energy usage, reduce your costs, and then minimize your environmental footprint too with that. You could generate a new business model. So leveraging your data to transition from selling products to offering services. So using as like an equipment as a service standpoints where manufacturers, customers may pay based on the usage as opposed to owning the equipment. Some competitive advantages that manufacturers will definitely see, just preventative maintenance. So again, just it's another kind of big buzzword that's thrown around, but it actually means a lot. So less downtime, less money being wasted, better utilization of those human resources in terms of prediction, compliance, regulatory, driving innovation, optimizing supply chain. There's a ton of different advantages. And then just identifying any inefficiencies you currently may have, especially with big factory environments that I've seen. They've been running for so long. Those equipments have been in place for just, again, so long that understanding them a little bit more and finally using the data to just understand what they're doing and predicting kind of just that downtime, I'd say is one of the main keys in terms of competitive and business advantages.
I think those are all great examples of the benefits and how to drive business value. And I know we'll come back and dive a little bit further into that because there are some questions coming up on that topic. But I want to talk a little bit about collecting the manufacturing data. And so, I grew up in the chemical world where we hardwired everything to the control system and then to our data historian. And when we wanted to do predictive maintenance, as you mentioned, Kelsey, is one of the opportunities. We would do monthly vibration checks on motors, for example. And yes, that'll tell you if it's starting to fail, but you can't really predict because it's not enough data. And so being able to put on IoT sensors and actually monitor that live in 1 minute, 5 minute intervals, whatever it is, you can successfully predict when it's going to fail and be ready for a secondary pump or take it down for maintenance and plan your production around it. So there's so many advantages. But in more detail, Kelsey, again, how can manufacturers effectively integrate IoT sensors into their existing infrastructure to maximize operational efficiency? As I mentioned, like in chemicals, we already have all this hardwired stuff, and now we want to add IoT, and I can see the complexity as each IoT sensor might have their own data hub, and it needs to all somehow come together some way. So what do you suggest?
Yeah, I think the first thing what we do is we call them like automation audits with the automation groups that we've done for more of automation equipment. But I think it's a really good model for kind of first evaluating an IoT opportunity is really just understanding what the current infrastructure is and what the customer is looking for in terms of data. Data is such a big word, and if you don't kind of pinpoint exactly what they're looking for or exactly what the pain points are, you can put in any type of software solution, but it's not going to benefit the customer. So you really just have to assess that current infrastructure, go on site, kind of just walk through what they're doing, even if you don't talk about software the entire time, but talk to those kind of maintenance people, see what their struggles are, just really ask the good questions on what those customers' pain points are, while also just seeing their factory, seeing their environment, and just identifying exactly what you're kind of working with that. So once you're kind of able to do that, you can kind of come back, make some objectives, and clearly defining exactly what you want to do with the integration, and kind of put it into a plan. That's when you kind of put in the engineering resources, start to talk about timelines, also talk about the support part of it as well is really big in terms of resource allocation from both the customer, if they have a team in-house that's able to do some of this deployment and able to monitor some of the data, or if you need to kind of do provide some of your own engineering support or use like an integrator network as well. So planning on like who's actually going to be doing the person deploying this. And then coming back after you kind of are able to evaluate that with like an ROI plan as well to kind of show the customer exactly what they're saving in terms of human labor, human resources, and also just how much money they're saving. And then I feel like after you kind of do a lot of those steps, you can move more into the right platforms you want to use. So with us, being such a big distributor, we have so many different suppliers. So actually being able to choose the right platform that you want to use for the customer is half the battle. So kind of using those objectives, comparing them with the different technology that you have available, and just making kind of like a consultative sales approach and presenting on that. Also, two really big parts of it that you can't really miss kind of as you're moving along with the customer, the security and the networking portions of it. So making sure that if you're using someone else's technology, like we would be doing as a distributor, making sure that you've either brought in like a security expert from their end, or that you've just looked at all the white papers to make sure that the security is matching up with what the customer wants, and working kind of alongside their IT team to make sure you guys are kind of on the same page, because that's a really big part of it. So after kind of moving through those steps, and they get some buy-in, making sure you do some training with those people as well to get maybe a maintenance technician, see if there's any interest for that person to learn about vibration analysis, and bring in some resources to train that person on it if they do have an in-house team to do some of that data supporting. So that's what I would say would be kind of at least the process we've taken with getting new opportunities and new customers, and making sure that you're kind of identifying each category when it comes to just solving their problems with data.
Okay. And
if I can add to that, how we work with some customers. So typically in an industrial setting, you talked about sensors, right? You talked about the data it generates. Typically, the data that gets generated from these IoT sensors tend to be of time series in nature. So you need some sort of a tool that can store your time series data. And time series data, the nature of the time series data is at scale. You're looking at like a lot of data. And if you have like a big enough machine, like an earth-moving equipment or a gas drilling platform, you're looking at millions of sensors and billions of data points coming from that. So you need some sort of suitable time series database to connect and extract that data into that, store that. The other problem that you'd also have is in this Industry 4.0, right? If you want to do predictive maintenance, you got to be able to take that data and run it through some ML machine learning algorithm and so on. Like you mentioned, you need a lot of data points, which you will collect from all of these machines and so on. But then running through the machine learning algorithms, you need to give access to that data to your data engineers who would run through their own kind of in a cloud platform and so on and so forth. You're looking at data that's coming from the edge that has to be transferred onto some sort of suitable location that the field technicians can look at. Also, that they have to be sent to a central location in a cloud where your data engineers can act on it, run through some algorithms and push back some of the models, push back some of the predictive results. So essentially, you need to build that entire pipeline like Kelsey mentioned. So, it starts with, obviously, you need to get buy-in and so on. But I think there was a question here that, hey, how do I get started? You get started with maybe one of your motors, one of your things, and start to put in that sensor and try to extract the data. Once you build a pipeline that goes from edge to your kind of looking at the edge, you can use one of the tools like Grafana to look at the results, or you can push it into cloud, and then you can use a tool like InfluxDB that can store and work with your ML tools in the cloud as well.
So thank you for that. And I have a more specific question I want to add to that to see if you can answer, and you can help settle a debate. So one of our customers at Aperio, they have data from the process control network going to a typical data historian. They also have a lot of second tier assets where they have IoT sensors that all have a data hub. And they're questioning, well, where do I put the data next? Because we want to still do the same analytics. We want to do this. And there's a debate between going into their cloud, so ADX for this example, or writing it back into the data historian. And I think there's so much complexity on either way. If there is a recommended like standard path that you would have for that.
I can go first, and then maybe Kats can also answer that. I think you mentioned that data is coming from the edge. You want to put that into cloud or keep it in the data historian at the edge. Why not do both, right? So if you use some of the modern technologies like InfluxDB, we have an edge solution. You can install it on the edge. Our requirements are very minimal. Usually on the edge, you might have a gateway or some sort of system, usually a Windows box where you can install with a very minimum RAM and CPU requirements. InfluxDB open source at the edge really works very well for that. So you can install it. And you can also install some of the open source components like Grafana. Grafana is a great visualization tool. It has tons of things that they could work with. But once you install those, you might have to build some dashboards yourself. So this is one of the build versus buy decisions you want to make, because data historians will give you all the visualizations out of the box. But then the advantage that you will have with InfluxDB and Grafana is that you can build your own visualization. You can add new things, or you want to have additional context that you want to change data. You can do all of that pretty easily. We can expand and scale. The other thing you could do is you can send data from the edge into cloud. So we have InfluxDB Cloud running on AWS, Azure, GCP, whatever cloud choice of yours. You can run and you can say, hey, I want to send all of the data. Some people do that because they want to. You want to get as much data as possible to run your machine learning kind of learning tasks and algorithms, build those models. But if not, you can summarize that. Some of the customers would just summarize that data and send it over so that you can aggregate from a bunch of edge devices and look at the long-term trending, seasonality, and things like that. So you can do either of those approaches. Whether InfluxDB, it's a time series solution, that edge to cloud, and you can work with your data engineers and also work with your on-site field technicians to look at things in detail at that granularity that you're looking for. That is also possible. Yeah, I don't know if that helps answer your question.
That helps me, so thank you. Kelsey?
I would say to build off on that as well, we're we haven't done as much in like exactly the analysis or historian portion, but with, I guess, some of the suppliers we focus more on like the open software, open hardware kind of model. So we have a few suppliers that come to mind where they have like an agnostic gateway that you can just connect a sensor into. That's, for example, maybe collecting flow. It's a flow monitor, and it's collecting like water data. Being able to use different types of protocol to get that data, and using just that open kind of hardware right on the edge to collect that, and then combining that with like an open software platform, installing that right on the gateway or whatever you have installed for the hardware piece of it, and then kind of combining those two, and then sending that data into some type of database, kind of like InfluxDB. So being more of like a hardware provider from it too is the word I like to use a lot is just agnostic. So finding partners and finding equipment that it literally doesn't matter what equipment you're trying to get information from, that it can plug into any type of hardware, just using different types of protocols. So really looking for those kind of partners that it doesn't matter what on the factory floor that you're trying to gather information from. It's been huge in terms of evaluating like suppliers as well.
Thank you for that. And you've helped solve the debate that's going on. So next question. So what are some best practices that you could recommend for ensuring data quality and accuracy when dealing with sensor data in an industrial setting? And whoever would like to take this first. And data quality is actually one of my passions. And I'm really curious to hear how you're handling that in your areas of expertise. Balaji?
You want me to go? So some of the data quality efforts. Okay, so I'm not an expert on this end. I want to be very very honest with you guys. But some of the data quality efforts I've seen is, in InfluxDB, you can actually send in duplicate data as well. But we will basically, the duplicate will overwrite. So that's some of the things that happens. But otherwise, you can actually use some of the data cleaning efforts, but you probably would do it on the cloud side, right? So you get the data into a cloud location, and possibly you would have to work with your data engineering team that can run through some data cleaning efforts, and they can then run through whatever data pipeline they have in order for you to ensure the data quality is up to the limits, or up to the things that they have. And then I think we lost the host, and then send it back. Maybe Kelsey, you may have more details here that you can offer to the audience.
Yeah, I'm not a total expert on it as well, but I guess from what I've heard and just evaluating different trends, encryption, I think, on the data is a really big topic I've heard brought up. So making sure that the data transmitted between the sensors and like central systems is encrypted with strong protocols, and then authentication as well. So using multi-factor authentication to access that data. Transitioning between different types of using certificate keys rather than just passwords, having access control policies in place as well to make sure you're limiting kind of who can actually access that sensor data. Physical security is a really big one too. So with putting a sensor like out on the floor, having different types of seals and maybe like an enclosure, so people can actually like physically tap into that. I think that's one that people don't think of as much. Disabling unused ports as well on different types of IoT devices is a little tip I've seen people do. So those would be the main ones I've seen for making sure that it's quality data and accurate as well.
Okay, thank you. Let's see. How can manufacturers ensure interoperability and compatibility between different sensor devices and systems to enable seamless data integration and analysis? And this is kind of a different view of some questions we've already asked. And And as I mentioned, the IoT sensors that I've looked at, they all have their own data hub, and then you go from there. So what do you recommend, Balaji?
Yeah. So data interoperability is kind of the state where, hey, you have data coming in from a lot of different kind of you have different equipments that it has been installed on different times of the things. You might go to different vendors. With sensors, one of the advantages you get is some of these data, especially if you're monitoring temperature, pressure, humidity, those kind of vibration, things like that. They're numbers. Essentially, your data becomes kind of coming in numbers at a timestamp, and you can add in some additional context using tags. What we call tags is, let's say you want to say, hey, where is that equipment located in your floor, in a particular geolocation. You can even put in, any of the, kind of things. If it has an IP, then you can extract an IP. So whatever, all of the data context you can add as tags. So a tagged set of values come in as time series data. The advantage of that is now if you collect all of these sensor data, they are pretty much uniform in terms of standards. Now you can do a whole bunch of things. You store them in InfluxDB. Of course, you can have different tags and so on. But then InfluxDB with 3.0, with the latest release, what we have done is we're not using any proprietary formats. Typically, you'll see that time series data, they will use a proprietary format to store that in the backend storage. What we are doing is we are storing as a Parquet. Apache Parquet is one of the open data standards, open data formats, and we use a commoditized storage like S3, or if you're on Azure, then Azure Blob Storage to really store that Parquet files. With Parquet files now, all of a sudden your data engineers may be working on like an app machine learning tool or data lake or data lake house and things like that. Then those tools also understand Parquet. But the challenge now is, okay, what kind of data, what kind of columns are available in those Parquet files? And where are those Parquet files located? You might be having millions of them located in different buckets or segmented or partitioned by time and so on. So for that, we call it like a catalog. A catalog is usually you use an RDBMS like Postgres or things like that. But also there's an open standard, which is called an iceberg. An iceberg is kind of a unified standard that has a very specific format that can say, hey, these Parquet files are located here, and the metadata is located here. So what that allows the data lake tools to do is directly access the Parquet. Otherwise, what you will end up doing is you write some kind of an ETL, extract, transform, load, and then you take that data, copy that over into the data lake or data lake house, which you don't want. You don't want data movement. It's pretty expensive, inefficient. You give them access to that data, Parquet data, directly from the lake house. They can run their machine learning tools, and then you can push those models onto the edge. So all of these can happen. Now, all of a sudden, you have a system where all of the data can talk from one end, or can be taken from one end to the other without any issues. And it lowers the cost of operations. It increases visibility within your organization. Your data engineers can work on it. Your OT engineers can look at it. You can now do most of the advanced analytics that you can only think about performing. So some of these things, that's, at least from our perspective, that's what data interoperability means, which you take the data and make it available at as many systems as possible, so that everybody can look at it the same way and act on it in a uniform manner.
That makes sense. When you say everyone acts on the data the same way, and there's a saying that you won't have arguments if you're all looking at the same data. You won't be arguing about the data because it's all the same. Kelsey, do you have anything to add there?
Yeah, I kind of touched on this a little earlier too, but I guess with some of the customers we've seen is a lot of people have a lot of different sensor solutions. So again, that data is like very, very siloed, and those companies aren't the best at like sharing a bunch of that data back and forth. So, and that's hard to train customers on how to use if you deploy different 5 sensor solutions. train those customers on how to use 5 different types of dashboards and analyze 5 different types of data sources. So just making sure kind of what we've done with some demos and just testing is, again, back to that kind of like open hardware, open software, using a gateway that's able to talk to all 5 of those sensor dashboards as well, and bringing it into one dashboard. So doing kind of like the upfront work for the customer in the back end, kind of presenting and just being like, you guys have these 5 different dashboards, and I'm sure that's a big pain point to have to learn how to use all of those, but we have this gateway solution that has this really easy dashboard we can just create for you, where you can just view everything in one. From a customer perspective, that's been a really attractive thing. They can't even wrap their heads around that you can tie it all together doing that. So that's, I guess, more like on the customer side. We've just seen a lot of people asking for that, especially just massive plants and massive customers that have so many different types of those data sources. So it's just going along with the theme of just bringing it all into one, and collaborating with vendors to do that, like InfluxDB or any other platforms as well, but making sure you really collaborate with those vendors to just be able to access all of that.
I think it's a great segue into your next question, actually, because you need to be able to aggregate all of the data in order to leverage advanced analytics and machine learning techniques. And I was wondering, Balaji, how manufacturers can do that with all this disparaging data. Kelsey mentioned the aggregating, but how do we get from IoT sensors into leveraging that data, that sensor data, and getting to those insights?
Great question. There are a lot of open source tools available that actually can allow you to collect that data from the edges. Telegraph is one of them. It's an agent that you install. We understand many different plugins, including MQTT. But then the data, once it's available in InfluxDB, we have a number of things you could do. For example, you can just look at the data using, we support SQL or InfluxQL. So these are standard query languages. So you can query like, hey, select, if you talk to your, again, these need not be the OT engineers who can do it. You can build dashboards for them, but then the data engineers can simply do ad hoc queries using SQL or InfluxQL. It's a very simple select. And then there's a number of time series kind of functions we provide. Time series functions are, your data is coming in a large volume. So you can either look at individual data points, or you can say, summarize this for me. Look at all of the past day or past month data, but give me a summary by day or by hour. There's some standard functions for that. You can provide a time window, so you can run some advanced analytics from that perspective. The other part of the advanced analytics, I think we briefly touched on using the data lakehouse, is now you have all of these individual raw data points. You can use them in, there are a lot of machine learning models which actually specifically work on time series data and can do time series forecasting. There are non-machine learning forecasting models as well that you can run. ARIMA, which looks at average and things like this. Some mathematical, statistical methods you can look at. Those are also possible. They're very simple. I mean, they're not simple, but there's some functions that we provide to help them do that as well. And then machine learning, obviously we don't do machine learning in InfluxDB, but you can run, like you said, we can run machine learning kind of algorithms specific to time series analysis on your kind of tools, data lake houses, and then bring kind of the values. So machine learning tools, typically what they do is you look at a past performance and try to predict the future values. You can predict future values, and once you push that back into Influx, you can then do a comparison and say, hey, I'm actually predicting here based on my trend, but the incoming real-time value that came in from one of the sensors is actually here. So there's a difference. And using that difference, you can say, hey, is it within the margin of error, or is it something that it's anomalous and I need to have somebody to look at it, or do some predictive maintenance and so on. So there are a lot of those things we allow you to do within InfluxDB. So from edge on to cloud, and even with the data tools like data houses and warehouses.
Thank you very much. And we have 20 minutes left, and I would like to look at the audience questions. And this first one, Balaji, you've already touched on it. So how do you get a company with no experience with IoT and data collection to get started in a way so they can build on quick wins and build confidence in their ability? And you had mentioned how, start small, build that first pipeline and get going. But I was wondering, Kelsey, if you had something to add to that.
Yeah, I'd say most of the customers I've worked with and like factories I've gone into, most people aren't doing anything. It's all very manual processes. So I'd say getting started, using the partners that you already have in your kind of pipeline and evaluating, kind of asking them if they've done anything Industry 4.0 related and just seeing kind of what the different offerings look like. I would also probably look for, in terms of if you do have a partner already, but look for someone that can, like I said earlier, come in and kind of do like a full audit of your environment and to just see exactly what the infrastructure is and what it's looking like. So kind of have a company, have a team that you're able to find and leverage to just come in and kind of just hold your hands through a lot of that initial just getting started and then working very incrementally. We always say with what we've been doing, it's like a crawl, walk, run approach. So start really small, whether that be if you end up wanting to monitor something, look at like starting with like one machine or one line and deploy one piece of hardware that could collect maybe like 5 data points and then be able to see what that does to your infrastructure and your process and then kind of scale from there and add data points as you go along and add lines and machines as you go along too. But again, just starting very small and looking for partners that are able to have agnostic software and hardware capabilities that can talk to anything and also are going to support you in terms of the engineering support and do like a very consultative sale on just really focusing on exactly what you want to gather from using IoT.
Thank you. And I'd like to add one point. When you're starting out adding technology on your shop floor, and you really want to look at where is the biggest pain point and engage your shop floor workers to understand what do they need to know to do their job better as kind of a first win. And if you can record that, you put a sensor on it, you record it, and you actually improve something there, then you're going to get that buy-in on the shop floor a lot quicker. So let's see, next question. This is a good one because it's always tough. How to convince management of a company to go for such a futuristic approach to data acquisition, real-time monitoring, improving performance, OEE, et cetera. And what are the key points in business case? And it's hard for me, that word futuristic. But if you go and look at most traditional manufacturing, especially small to mediums, they don't have much technology. So when I grew up in Industry 3.0 doing all the computer control and things like that. And so I can imagine that those who don't have that same experience, this can be a bit overwhelming. And then to convince management, hey, you really need to spend the money because of the benefits. So what can you as experts add to that?
I could start. It's Tesla's a very well-known car company, but people don't know that actually they are also a data company. Actually, I would say Tesla is a data company than a car company because they generate so much data from all across the processes, from the gigafactory to how they produce cars. They even have, most people don't know, they also have a power roll that stores solar power generated from solar panels on home installations into batteries and so on. The reason I'm saying Tesla is I think it might be overwhelming if you think about everything. But I think one of the ways to think about this would be, hey, capture what you're doing today and see what's the value you could be getting in a futuristic approach like this. Like you said, like Kelsey mentioned, take a small project. Take the biggest pain point, take where a particular machine or an assembly line is actually losing money, and think about how this futuristic approach of using an open data standard, open tools, getting the data, working with machine learning and things like that will accelerate producing value. Because again, I'm sure you're in the business, you're in a company that supports accelerating business value, and what are those things? There's a lot of awesome materials available on Influx Data website as well, which talks specifically about industrial IoT and what are the problems we see and how do we position business value and explain that in terms that your stakeholders will understand. But that's one way. I mean, we got to change. Change is happening everywhere. So if you want, I mean, it's not an if, but I believe everybody wants to get into the future where, hey, things could be so fast, so process optimized that, we can do everything in real time. So I definitely go for that.
Yeah, to add on to that, I've heard the same thing. I mean, about Tesla being a data company. Same with Amazon. Like whether you like them or not, those are two of like the biggest companies in the world right now, and they both were founded on just really leveraging data and using that to predict what their customers are going to buy. And that has just exponentially grown business. So that it, from kind of like a competitive standpoint as well for companies, like to be able to just stay in the space, like you kind of have to adopt some of this if you want to continue to be competitive with the current economy and the way it's moving and stuff. So it's kind of like if you want to continue to have a business, if you want to continue to be competitive, you really have to stay up to date with the trends, with the technology coming out, and this is kind of the next step for manufacturers.
That's great. Thank you. So let's see, next question. So what are some of the main functional differentiators of IoT sensors as compared to conventional sensors? I think this is a great question because the conventional sensors that you see like in chemical plants, oil and gas, they're very expensive and they're primarily hardwired. So what kind of differentiators do you see in IoT? Either Kelsey, you want to go first?
Yeah, I would say, I guess, starts with just the functionality of them. IoT sensors are specifically designed for industrial environments and are more kind of rugged and durable compared to normal sensors. And the connectivity part as well with functionality. So being able to kind of support protocols like Wi-Fi, Bluetooth, any type of cellular connectivity. So just being able to transfer that data using those protocols. Other sensors aren't able to kind of use and output that data as well. And integration with IoT platforms when it comes to IoT sensors, they're, designed to integrate into those kind of platforms and ecosystems, allowing for easy deployment and staying with the kind of the industry protocols to make sure that all devices and systems are connected to that. So, and I'd say more of a normal sensor would require a lot of customization and integration and really hard programming to be able to get that data out of it. So those are the first kind of things that come to my mind with the differences.
Okay, thank you. Balaji, do you have something to add?
No, I think she answered it perfectly. Yeah.
All right, thank you. Let's see. So what kind of challenges have you seen? So you've both worked with customers quite a bit. What kind of challenges are you seeing in the manufacturing, keeping companies from being able to adopt Industry 4.0 capabilities? So what are the biggest things that you're seeing that's stopping adoption of new technologies?
I can go first. I think the biggest adoption is, the adoption blocker would be getting consensus, getting stakeholder, getting everybody to aligned on what exactly you're doing, right? So once you get the data, once you align everything, and then once you get the data somewhere, we are pretty good at, okay, let's extract the data to make them useful. But getting started, I think that those would be one of the biggest blockers. And I think we already talked about maybe start small, take a particular section or particular machine or particular equipment, see where you're lacking, and try to get everybody, try to do an assessment. I think Kelsey covered pretty well during an initial section about doing an audit, getting everybody involved into that audit. There's some specific scaling. I've seen consulting companies work. There's some specific, I think Kelsey's company could also do this. I think they audit your environment and they can tell you, hey, is your equipment really internet enabled? Because again, all of those IIoT sensors, the idea is, okay, you need to get that data somewhere, and establishing those kind of assessment is required for you to understand how do you install the sensors? How do we get the data across? How do we extract that data and put it into a place where you can interoperate, you can apply machine learning and things like that. So, getting started would be a biggest blocker, and some of the challenges that Kelsey mentioned earlier are important.
Yeah, I would say totally agree with all that. I would say just making it a priority. And again, with a lot of customers we've seen, it's still, I think, it's where the market's going, but I don't know, at least our customer base, if they're fully there yet to just truly make it a priority. It's like a nice to have solution. Like it's not totally critical to their daily production processes to make something like this. This will just make them better. So it's not like they're more focused on what's exactly happening on the floor. So kind of just maybe taking a step back and just being like, okay, we don't absolutely need this, but it could make us a lot better in the long run. And we're going to have to do some initial investment. And that's a big part, I think, too, is the initial investment in terms of like buy-in. It's going to take a little bit before you start to see like the direct like ROI from it, but just making sure, just keep it a priority and just invest. You have to invest a little bit, but just from all the trends out there, just the things we've seen, it's definitely worth it. So I think, again, kind of going to the first question is kind of just, I think the main thing holding people back is just kind of themselves and just really just dialing down and figuring out the process. I think the sales process too for IoT technology, it's like a little bit longer. It's a longer sales process than, I don't know, like for our automation companies than selling a robot or something. A lot of our like automation salespeople are all kind of very focused on like the hardware side, and the software side and actually getting customers to buy in. There's a lot of other kind of like loopholes you have to go through with customers in terms of figuring out their IT and figuring out kind of what you're going to do on the networking side of things. So it's a longer sales process, but you kind of just got to buckle down for it if you really want to see like those main impacts that IoT and connectivity will have for you.
So I agree with everything that y'all are saying. And what I see is that the hurdle to get started, that expense of adding the compute power, the cybersecurity compliance, and everything you need with IT is difficult. One thing that I did in my past when to get buy-in from management was we actually calculated all of the unplanned outages in 1 year's time, calculated how that affected our EBITDA because we were in sold out conditions and lost quite a bit of production, and used that for years really to leverage the work that we wanted to do and to be able to get those first approvals. Hey, we need additional compute power, we need additional software, we need to get started, start correcting those pain points. And then after that, in an iterative fashion, it became easier because they saw the value from that. But that first step is really the most difficult because you have to get some hardware in place. Even with IoT sensors, you have to have some sort of hardware in place, but there are multiple ways to actually read the data. And it's not nearly as complex as having to install a full data center and things like that. So thank you for that. So back to data quality. So what about the metadata and best practices in the metadata? Because when you want to have actionable insights, you not only need quality data from a time series standpoint, but you need to understand where it came from, what it is. It needs to be fully contextualized, and that's often done with metadata. Or you can add your human context onto that as well. But what have you seen in some of the best practices?
I can start here. I think the at least I can tell you from an InfluxDB perspective, InfluxDB point of view. So from InfluxDB point of view, all of these additional context, things like which machine, where is it? Is it coming from this sensor, this PLC? Is it coming, and any additional context under which circumstance this data is being embedded, and those kind of things, they can be appended as what we call as tag. A tag is nothing but you kind of have a key value, and you provide a field and a value into it, and that's what we call as tag, and then you add it to the data. The beauty about InfluxDB, again, not every tool can do this, but one of the things that InfluxDB does very well is you don't need to define this data before. You can start to collect your data, and let's say that you're missing context, you want to add it, you can add an additional tag. What simply happens is it'll create a separate series and start to measure that. You can combine the data together using our query language, which is pretty advanced in combining data series and so on. I'm going a bit technical here, but I believe that understanding of the tools, and I believe also you can now organize however you want. You can start with, hey, I want to start with my building, location, region, location, building, floor. All of these can be actually organized in such a way. We are pretty open and flexible in terms of how you collect that data and put it as tags within InfluxDB. So that's why we don't recommend, hey, you do this, but our tool can actually almost take anything, and you can interchangeably change that later on without doing any data migration. I don't know whether that would help answer this particular question, but I thought that was important to mention.
Okay, thank you very much. And we have just 1 minute left. Are there any, words of wisdom you would like to pass on to our audience on the IoT sensors?
Yeah, I can go ahead, Kelsey.
Okay. Yeah, I would say for, I guess, manufacturers, again, looking into solutions, kind of just starting to do a little bit of like an internal audit, I guess, maybe before bringing in companies to actually look or make a solution for you. So start to just look and find what your main pain points are that you think collecting data and using data could help solve. And I think that will build a big enough motivation internally for you to truly invest in looking for the outsourcing those resources. So just looking internally, also going to kind of like the plant floor. The plant floor has so much insight. I had never really learned too much about the plant floor. I never really had a background in manufacturing before this job, but that was part of the first kind of few months of my job, was to go around to random factories and just talk to maintenance people on what their biggest struggles are, and if they had a dashboard that could help them kind of view different trends and help diagnose machine equipment errors. Like, what would that look like? And it's crazy the amount of insights you can just get from those operators and those maintenance people. So there's a lot of really valuable information that you can do in terms of finding pain points from talking to those people and just looking internally within your company too. And then all the solutions out there, kind of once you're able to pinpoint like what those pain points are, there's so many resources. So just making sure you're aligned with people that have, or companies that have similar goals to you in terms of what you're looking for in terms of these kind of solutions. So it's two things I would say.
Thank you. So I'm sorry, Balaji, I'm going to cut you off. So thank you very much to Influx Data for sponsoring this session. And I appreciate everyone's participation. The questions that weren't answered, we'll try to do those via email, and you can reach out to any of us online. And next is the Insight Factory, driving decision-making with AI and machine learning. So thank you for your time.
Thank you, everyone.
Bye-bye.
Thank you, Jane, for facilitating this.